G'day chemists. So welcome to IB question of the day number 6. We're sort of travelling on our road to the IB, those exams, and I hope it's travelling well for you. Today we're going to have a look at a question that's a multiple choice question, again, from, I think it was last year's IB in the November section. Alrighty, so here's our question. Pause it, have a crack at it, and then we'll come back and we'll work through it together. So the question is, what is the atomic mass of the relative atomic mass of the element as determined from its mass spectrum below? Alrighty. So first thing it gives us is it gives us the percentage abundance, which is important. We've got the values here. We're not expected to read it using a ruler or anything. It gives us the numbers there and the mass to charge ratio, but essentially this is just the mass, right? So we have a mass of 10, 80.1% of it is 10, 11, 19.9% of it has a mass of 11. It's always that because the charge is always plus 1, so it's like mass divided by 1, so that number is it's the mass to charge ratio, but it is just the mass. So we use an equation for this, and that's the relative atomic mass equals the percentage of mass, or the sum of the mass times abundance divided by the total abundance. So let's have a look at what that looks like. So in this case it's 10 times 80.1 plus, because it's the sum of, 11 times 19.9 divided by 100, because these two numbers add up to 100. If they didn't, we'd have to change it. But as a percentage, it's always going to add up to 100. And that gives us a 10.109 or 10.2, which means our answer is B. Pretty straightforward, but there are some key takeaways we'll look at. So first off, this question punishes those who rush. It's not a hard question, but if you just try and eyeball it and move through because you think the multiple choice section is a part to sort of charge so you're short on time, and you are short on time in the multiple choice, this will punish you if you rush it. They all will, but so what that means is the misconceptions they're looking at when you're rushing are simple, right? This number 10 is the dominant isotope, so you're like, oh, it must be 10. Bang. That'd be incorrect. It's somewhere in between the two. These are the two, so it's going to be 10.5, 10.5. That'd be incorrect. And also, this is just if you're not reading it properly and you link this 80, so 0.8, because 80% is 0.8 as a multiplier. So if you link that to the 10 down there, that'd be a mistake as well. So in other words, do the calculation. That is the main takeaway. If you're given a question like this and you know you can calculate it yourself, or as opposed to eyeballing it, because I mean, with a lot of experience, like I could probably eyeball this question, but I still wouldn't do that in the exam, right? Like I would make sure I'm checking my work, doing it properly, do the calculation. Okay, if you have any questions or feedback, get back to us as quick as, or let us know, and we'll get back to you as quick as we can. Thank you for watching. Don't forget to subscribe so you can keep up with all the questions of the day as they keep coming out, and we'll see you next time. Bye now.